Hi everyone, let's take a look at another homework question from the textbook. This time we're looking at number 12 from the textbook on page 83, I think. Okay, so let's read the question together. Do the functions y equals 1 over x and y equals x cubed ever have the same slope? If so, where? So when they say, do they have the same slope, and I copied and pasted this from the textbook, the idea is that do the tangents drawn on the graphs of these functions have the same slope? So the idea here is that we are trying to look into two different equations. So this is the equation of a rational function or reciprocal, however you want to call it, y equals 1 over x. And here goes the function y equals x to the power of 3. So if the tangents have the same slope, that means that these two functions will increase or decrease or will change at the same rate at some point. So how do we measure that? Derivative is the answer. So we're going to say that if I want to compare their slopes or the slopes of the tangents or the derivatives, it means that I have to determine the derivative first. So I'm going to find dy dx for 1 over x. But before I do so, I will write it in power form because at this point in time, it's the only formula that I have learned. So instead of writing it as 1 over x, I'll write it as 1 times x to the negative 1 or simply x to the negative 1. So dy dx will be negative 1 x to the power of negative 1 minus 1, or even better, negative 1 x to the power of negative 2. So the derivative is negative 1 over x squared. So that's the derivative, dy dx for the first function. Now let's take a look at the second function, which is y equals x cubed. So dy dx in this case would be equal to power rule 3x, 3 minus 1, 2, so that's 3x squared. So here goes the equation of the derivative of the first function, and here goes the equation of the derivative of the second function. I just realized I have to switch the colors here, just for consistency. And we have to make this rectangle perfect. Oh well, trapezoid works just as fine. We're going to leave it as is. Okay, so the idea is that we need these two slopes of tangents to be the same, or these two derivatives to be the same. So let's put them together and see what they make. So we're going to say that negative 1 over x squared must be 3x to the power of 2. So we are to solve the equation for x, and as you can see, we have x in the denominator here, so we'll multiply both sides by x squared. So that means multiply by x squared both sides of the equation, and we'll get negative 1 on one side equals 3x to the power of 4. So in other words, we're going to have x to the power of 4 equal to negative 1 over 3. And as you can see, to solve for x, we have to take the fourth root of negative 1 over 3. Remember that number 4 is an even number, and the eventh root of a number has to be a positive. So with a number inside the root has to be a positive, because the eventh root of a number exists only for positive numbers. Since we ended up with a negative, then we're going to say this number is undefined. So what does that tell us in terms of our question asked? So if we are unable to find an x value that guarantees that the derivatives or the slopes of the tangents at each respective function are the same, it means that it is not possible to have the same slope. So that's the end of the question, and I hope that made sense. And bye for now.